There's too much space between the pellets. The compressed air blows straight through, and the material fails to flow.
Well, what do we do? The perlite is not going to work. This is obviously not going to work.
Right.
Do we just go to the standard sand that we know probably will work?
I mean, sand is readily available. It's natural.
Yeah, I mean, we know it works on a small scale, but can we make it work on a big scale?
I think therein lies the challenge.
So perlite didn't work, clay didn't work, so we're going to try to fluidize good old sand. But a lot of it, so it's going to be tough.
Cool.
Hey, guys.
Nice sandbox.
They're gambling on sand. It's cheap, but at 100 pounds a cubic foot, it's the heaviest option. And that could be a problem when it comes to the size of the sand traps.
Big. A lot bigger than this.
We need to make a much bigger tank, big enough that we can sink an entire vehicle. But we've also got one more problem, and that's you wouldn't expect to see a sand pit outside of a bank. So we need to come up with some kind of paver. It needs to be durable, but it also needs to sink once we fluidize the sand.
While Nick and Deanne hunt for paving material to make their sand barrier invisible, Chuck and Kevin need to make a much bigger prototype of Nick's air system and fluidize 10 times more sand.
We need to figure out a way to get a lot of air under a lot of sand and do it uniformly.
Right, well, we have our sand pit, and we could just do one big tank, the manifold that runs through our entire system.
Right, but then we'll get a lot of pressure drop between here and here, and it won't be uniform at all.
And that means a lot of fluidization here and probably none there.
Yeah.
We can't have that.
Yeah, I mean, we could solve that by adjusting the size of the holes to try to make the pressure uniform across the whole thing, but I think a better way to do it is to just have the tank and then put several tanks here.
And each tank has its own manifold.
Exactly, yeah, and we'll just run one after the other, like that. And we'll get a little pressure drop between here and here, but it won't be as significant.
No big deal.
Yeah, I think that's the way to do it.
All we gotta do is make them.
Make a lot of them.
Yeah.
Chuck and Kevin are building a working prototype of their final air manifold system.
All right, let's see. I'll start with these.
To keep the cost down, they're using a standard plastic pipe, the kind you'd normally use to plumb a house. And with the sand costing just $15 a ton, if the system works, it's cheap and easy to mass produce. The pipes have to be tough enough to handle a lot of air. 1,000 cubic feet per minute, delivered through 114 air holes, each one drilled by hand.
Bring it in and set it down. All right, one down.
Gajillion to go.
Gajillion.
Coming up, Chuck and Kevin test their manifolds inside a big green dumpster. In the process, they'll learn that even when you play with sand, life isn't always a beach. The Smash Lab team is trying out a crazy idea, using sand pumped up with air to create a state-of-the-art security barrier. So far, it's worked on a small scale, but now it's time to up the ante. With all the air manifolds finished,
Dump it.
Chuck and Kevin call in 18 tons of sand
Get the dumpster around.
and a big green dumpster.
All right, stop there.
Inside, they're going for 4 manifolds. But big engineering brings big problems. They have to dump air into all the manifolds at the same time. So Chuck's got a new piece of equipment, solenoid valves. These valves operate electrically, so Chuck can synchronize them all to open exactly on cue. For air power, there's a matched pair of 400-gallon tanks.
We have the plumbing network all in place inside the dumpster. We filled it with sand. Last thing to do is connect the wiring for the solenoid so we can trigger all the valves at the same time, fill the tanks with air, and we'll be ready to blow it.
The 4 valves connect to an electrical circuit that Chuck can trigger remotely.
Ready to go.
The big green dumpster is ready for playtime. So Chuck and Kevin prime the tanks.
All right, flip it on. We want to pump it up to 110 PSI.
To succeed, the system has to have 18 tons of sand flowing like a river in less than a second.
You ready for this?
I'm ready. Okay, what do we have?
110 PSI in each tank.
All right.
All we gotta do is plug this in, trigger the valves, and hopefully what follows is fluidized sand.
We will dump 800 gallons of air into this thing. You ready?
That's it, man. Do it.
All right, here we go. Whoops.
Looks like someone forgot to plug it in.
I got no light, no power.
The real gremlin is a faulty generator.
Well, our only option is to get another one.
Yep, let's get another one in.
As easy as that.
You know, you get everything set up, you think it's all ready to go, and then you have a weird problem like power. The Jenny is just not working. I don't know what's wrong with it. So we'll just replace it.
There we go.
All right, everything's gonna work perfectly this time.
All right, plug that in, and hopefully we'll see some fluidized sand.
All right, here we go. 3, 2, 1.
That worked out better than I could have expected. Now, I guess the question remains, is that enough to stop a person?
One way to find out. All right. All right, you ready?
All right, I'll see you in a little bit.
3, 2, 1, fire.
Yeah, that wasn't so bad.
Can you move?
Honestly,